so to say, in policy relevant aspects, let me stress 3 key points in terms of what I think you should take on board for the further discussions today and tomorrow. Firstly, the fostering and continued improving of statistical data infrastructure remains essential. Statistical data summarizing human activities are directly linking to the single drivers of anthropogenic emissions and to the individual countries' mitigation efforts. We thus need accurate and detailed information on these activities. Secondly, an approach which complements this traditional territorial approach is needed. We would call this, for the sake of discussion, a transboundary approach, which includes both moving down from the national level to smaller units and moving up to the regional or even global level. Ways of monitoring the atmospheric greenhouse gas concentrations at lower levels closer to the surface, in addition to satellite observations, will facilitate the identification of the contributions of hotspots, such as large cities or industrial complexes, not necessarily the country totals. This, of course, is less relevant for the reporting to the UNFCCC, but even here, better data could improve over time our inventories. The point is that its NDCs will be implemented at various scales, including the local scales. Several local governments, such as those ones coming together in the Covenant of Mayors, started strengthening climate actions in their municipalities. Industrial facilities have also an important role to play. So such multi-level governance asks for monitoring of greenhouse gases not only with national totals, but also with spatially resolved emissions. And thirdly, a real transition is needed towards climate neutrality, as was also pointed out at the start, under the head of the Green Deal. Deep transformation of society and profound changes in behavior require new ways of communication, facilitating perception of something which is invisible, like it was in the case of the ozone layer, visualizing those trends and mapping the hotspots, not only for Europe, but for the whole globe, will be needed for the understanding and continued commitment to curb climate change and get citizens and keep citizens on board. And let me close by saying, as climate mitigation progresses, which we all hope and work on, I think the basis for all reporting will continue to remain the traditional activity-based bottom-up approach to greenhouse gas inventories. Nevertheless, direct observation is well established, and it will become a never more powerful source of complementary information over the years to come to inform policy. So on this note, thank you again for the invitation, and I look forward to interesting discussions today and tomorrow.
Yes, so thank you very much, Peter, for your words, and I hope that this is really announcing the dish for today, the menu for today, and so I hope that you are curious to learn more about this new Copernicus service that we are setting up to monitor anthropogenic CO2 emissions and contribute to the verification of the important CO2 budgets. As you saw from the agenda, the webinar will consist of 4 parts. So 2 this morning with a break at 10:30 and finishing around 12:30. Tomorrow we continue again from 9:30 to 12:30 with a break more or less the same period, focusing on the necessary measurement. Said that, I think I really wish to pass the floor to the real experts while we are reaching almost 200 participants to the event. So I wish you a very interesting webinar and count on your advice, participation in discussion part, because as said, is not a one-way discussion. It's not for us to tell you how things have to be done, but also to get your feedback and input to improve what we are doing. So we will remain at your disposal also after the webinar to answer your question. I don't know if I have to give back the floor to Hugo or directly to Greta. Please advise me.
Okay, Mauro, thank you, and thank you, Peter, for your introduction. I think I would, before I open the first talk, I would like maybe to say a couple of words still on the way this is work. So in Slido, as I said, there's a possibility to ask questions. So, and I'm supported by a number of colleagues, which is actually great. Then Mark Dowell and Eric Anderson and Dana Pinty, who is my co-chair for the second day, or is chairing the second day of this workshop. And so this will help me in moderating these questions, and in some cases they may as well answer your questions directly in written. So I just wanted to introduce them to you, that you know who these people are and why they are all of a sudden saying something on your questions. So with this, I would now like really indeed to give the floor for the first talk, which is a bit on the overall initiative and the policy context. So, and this is Gret Janssens-Manhout and Andreas Pilsecker. So the floor is yours. Thank you.
Good morning, everybody. I hope you do hear me. I will share my screen.
Hello, great. Actually, your presentation is being shared, but you can control it by changing the slide on the left of your screen.
Okay, but I don't see my presentation.
Yes, I also don't see the presentation.
I don't see the presentation. Maybe the easiest is if I share the presentation from my screen onwards.
Perfect.
Screen. Oh, no, screen too. No. Share. No. Screen. Stop sharing. I will in any the others share. Screen too. Okay. Now sorry for this. So I hope you do see our presentation that we prepared to introduce the policy needs for this entire Copernicus CO2 initiative. We are very happy to have DG Klima on board of that, also in our CO2 monitoring task force. And Andreas Pilsecker is our counterpartner in the task force there. And together with Andreas, we have been preparing this presentation. Andreas, are you there for presenting the first part? As I don't hear this, I will continue with the slides, definitely. We will see more information. For more information, we can always contact Andreas later on. So I would say 2015 was a special year in which we saw two things. We have the Agenda 2030 for sustainable development, and we had the Paris Agreement. And the nice thing is that all UN parties were really on board, almost equally called to contribute in working towards a sustainable world, and as well to have together to combat climate change. Now the Paris Agreement is really a landmark agreement for three reasons. First of all, we don't work anymore with Annex 1 and non-Annex 1 countries, but really we consider all countries in an equal way with what they all can do, and so we ask for them to come with their nationally determined contributions. Second, we have seen there that mitigation is not the only thing, but we will need to do as well adaptation. And last but not least, the Paris Agreement was working on an enhanced transparency framework where all countries can present their emission inventories, where there is a view on that together, a review as well, and a dialogue to have a good, comprehensive and common view on the situation, and where that is then taken as basis for further strengthening the nationally determined contributions. And I think that that was a very, very important step forward on what we have had already from UNFCCC, which was by then already 25 years in place, but which needed a further strengthening of the action. Now, what will we do in Europe, or what were we doing already in Europe? First of all, with the Kyoto Protocol, we had already the 20% decrease by 2020 of the greenhouse gases versus the year 1990, which is this year. Under the 2030 climate change package, a climate and energy package, my excuses, that was then further reduced to 40%, and under the van der Leyen Commission, we will further go for a climate ambition of 55% reduction. This is done by looking and enhancing in particular as well the renewable energy share, working on increased energy efficiency, and then we of course want to go to a climate neutral continent by 2050, as Mrs. von der Leyen is visioning for us, where it will be needed to have our forests functioning as a carbon sink for the remaining emissions that cannot be cut off. This is then introduced for each of the countries in national law, and we will have to track this. Now, this is then as well reported to DG Klima and as well EEA, and that it comes then together when it goes further to UNFCCC under the under the UNFCCC enhanced transparency framework. And the UNFCCC has foreseen already several types of review in a certain way. So there are already today the annual reviews of the national inventories, but there will be as well the facilitative multilateral considerations of progress, which will be biennial reviews in which regions will come together and will look at a common understanding of the emissions over their region, looking at inconsistencies between the different countries. And there, observation-based evidence will be very important. In addition, we have as well the global stocktake to have a complete picture of the situation where all the inventories will be put together in a complete picture. Also, international sources like from international shipping and international aviation will be in there. And from there, all the UN parties can look on what can be done further, where do we have some lacks or inconsistencies, gaps, and where can we further strengthen the information and the measures then that would be needed under climate action. These rules need to be, of course, established when you look into inventories. And the Katowice rule book from 2018 has produced the modalities and procedures and guidelines for this global stocktake. We have already from UNFCCC the guidelines established. That was already one of the first tasks that UNFCCC has given to the Intergovernmental Panel on Climate Change. In fact, already in 1995, there were already the first guidelines. Now it is, these have been further revised, and we have been coming to the IPCC guidelines 2006, in which also for the land use change and forestry sector, there were the good practices, and it has been as well further refined in an exercise that was concluded last year in 2019. Now, in Europe, of course, we take as well these guidelines as basis because we need to report all in this common framework. And 27 EU member states today, plus the UK, they have to report by the 15th of April to the UNFCCC. This goes first through a reporting to the EEA, the European Environment Agency, and the European Commission, the European Commission Directorate General Climate Action, which is responsible for the submission then. Now, there is a whole group of people involved in the QA/QC procedure for these inventories to check whether there has been nothing forgotten. This is based on statistics and emission factors, and it's very important to see that the quality is there. In fact, the UNFCCC and IPCC guidelines, they prescribe us in particular in the guidelines to have a transparent, a consistent, comparable, and a complete inventory that is as well showing accurate information. The Joint Research Center and Eurostat, together with the European Environment Agency, are looking over that. That is as well laid down in our EU regulation for the monitoring mechanism for greenhouse gas reporting. That is also the legal basis. And this is as well what is shared with the working group 1 of the Climate Change Committee that Peter Zapfel and Andreas Vilsecker are sharing and having best practices exchanges with them. Also, quite some of you might be listening here. And we are very proud that we have this good collaboration with the national inventory agencies. Now, under these guidelines and methods, there has been as well an increased movement away from what was there in the beginning proposed as at national level with default emission factors at what we call a tier 1 approach. So where you have generic emission factors and the use of national statistics with the methodology of IPCC, you can calculate your national emission inventory. You can, of course, refine that with country-specific values if you have more information, using as well more local data at a land use level. And that is even promoted to have it further refined towards a tier 3 level, where you have geotracked statistics, so facility data, and even emission processes modeled and having that data all introduced, which gives you an improved coverage in representation. So you have a better local representation of your in your emission inventory, and it can as well help to reduce the uncertainty. So going away, well, we further have updated our full series of IPCC guidelines with the 2006, which are the reference guidelines, and with the 2019 refinement added. This is really a reference that is used at the moment as well locally, even by some urban inventories. Also, the Covenant of Mayors has been looking at the IPCC guidelines as a reference, but there is an increasing interest in these local inventories. Why? Because local actions are as well taken, and you would like to see the process there. And therefore, it is as well so interesting and important to have a kind of hotspot monitoring. Now, what do we see when we talk about the monitoring? We start, of course, from a fossil fuel inventory, which we can grid into emissions. Now, these emissions are, of course, today is the big part still of the CO2 are the fossil fuel combustion, which are quite stable inventory. Now, it's important that we put this into a model to see as well how these are then concentrations into the atmosphere. So from emissions, we need to go to concentrations into the atmosphere. And that is what we can measure as well. Now, these emissions are injected in the atmosphere on a very heterogeneous manner. So although our inventory might show trends that are not changing 50% from one year to another year, what the atmosphere is seeing is quite different from one place to another place. And it is, in fact, very nice that with in situ measurements and with space-borne observations, we can see such plumes in our measurements. And this gives you then extra observation-based evidence for our inventories. Now, this is important because these are the big emitters which we want on the long term to have decreasing. And the synthesis for the countries is as well that the actions will have to be at a local level. So a whole cycle which is connecting to each other is there. Now the big challenge there is
2 minutes left.
The big challenge is that what we have as CO2 level nationally is what is this patchwork, whereas what we measure is of course representative for a certain area and doesn't see the political borders. And therefore it is important that we have a full model in between, that we take as well some ancillary data there. Now, as mentioned, the monitoring challenges are relatively small at country level. If we look at the average percentage per year, we talk about a few percentages, but locally, we see if we would take the average percentage in the period 2007 to 2012, this is as well shown here, for instance, for Paris and Berlin. You see that although this is for Germany and France also is a reduction in emissions there, you see that's very different on the local scale. So here you see a rather background increase, but then a reduction at local level, whereas here you see at local level increases and a background that is decreasing. And that is information that is very important when we want to track measures. And that is, of course, for the entire European continent, so important if you look at these changes from over in the global stock takes, which will happen every 5 years. And that is what is a little bit the outcome of, let's say, what we have seen as the crisis in 2008, as well as the extra greenhouse gas reduction measures. You see these differences, mainly blue is a decrease. That can be as well some dots that are point sources there. Now, today we see another experiment that we did not opt for, but we have the COVID-19 and the lockdown, which had as well quite some impact on our emissions. And we see here a monitoring, I would refer you to the Carbon Monitor website, where we can see what has been a decrease or an increase compared to last year for Europe. And in total, a 12% decrease is what we have seen. So as a final conclusion, I would like to call that for a spatial and a temporal disaggregation to enhance the follow-up of the nationally determined contributions. An efficient follow-up may really benefit from that. Why spatial disaggregation? Because the actions are at local level, and the air quality community, the conventional long-range transport of air pollution, has been shifting as well from inventories to grid maps in their submissions. Temporal monitoring might help us because if we think of today we are discussing about the recovery package, and if we can efficiently have the measures in a green way there where they should be, it's very important that we can monitor the implementation of these measures and adapt when or reformulate them if we see that it's not going in the right direction. We should not wait too long. There is no time anymore to waste. Now, larger variations are definitely seen at higher spatial and temporal distribution, also with large uncertainties from time to time. However, these can be monitored in a very transparent way. We see as well citizens going to their location and informing as well inventories, as well as a whole system of what they see locally that could be acceptable to them, or let's say verified by verified is a strong word, it should be rather, let's say, acknowledged by them, and what can't be acknowledged by them. Now, last but not least, if we can visualize where actions has really reduced the plumes, that might help solving us the real climate change problem. I would refer to the ozone problem. Also there, the visualization of the ozone hole was quite crucial for solving that problem. And with that, I would like to thank you. If you have some questions, also Andreas, myself, we are very happy to help you further or to inform you further. Thank you.
Yes, thank you, Gret. So I would like to encourage everybody maybe really to ask questions. If you have any on this Slido tool, you please register and make this interactive, or take the opportunity to make this an interactive event. I think maybe I would like to say, as Andreas was not able to join, I think really it's that the speakers, those who are registered as speakers, they are able to unmute themselves apparently. So just to be clear for the future. So I'm sorry again, Andreas, that there was this misunderstanding for the previous talk. So with this, I would now like to give the floor to my colleague Hugo Denier van der Gon, who will basically complement what Gret just said and explained from from the specific views of the inventory community. I see your first slide is up, so Hugo, the floor is yours.
Thank you. Yeah, it's always funny that I can say thanks to Hugo. My name is also Hugo. I hope everyone can hear me.
Yes, that's fine.
Yeah, okay, thank you very much. So it's my pleasure to share with you some views from the inventory community and the possible need for a CO2 observation from space. I'd like to make an important disclaimer. I'm an inventory compiler. I have many years of experience in inventories making, but obviously I do not represent the vision of all inventory compilers, so everybody is entitled to another view, but I hope that many of you will recognize what I say. Let's see, now I need to find the button where to move my slide. How do I do that?
On the left of your screen.
And there?
You have a bar.
Yes.
With a
Next
little
page.
number. Yes,
Okay.
perfect.
It's working. Thank you very much.
You're welcome.
So first, something about CO2 and inventory compilers. For us, fossil CO2 is actually the best known and easiest pollutant. It's you know, if you know how much coal is being burned in a coal-fired power plant, you just know how much carbon there is, you know how much CO2 is coming out of it. It's fairly straightforward. This is very different, for example, from other pollutants like particulate matter or NOx, which are much more dependent on the technology and the conditions under which you burn. So for us, CO2 is the easy one. And as a result of that, the uncertainty at the national level in the European Union is really small, in the order of a few percent. And I illustrate that here with a bar chart that was made by UBA Germany, based on their national inventory reporting. And what you see are a number of gases, so CO2 in the left, and then methane and N2O to the right, and a number of different source sectors. And it doesn't really, you don't have to look at the different source sectors. The real message here is that the flat tiles, that you don't even see the bar, that's CO2. So the uncertainty is really, really small. And so you can question yourself, is the CO2 satellite actually going to help us to reduce this further? And really, when we think about that, the answer is no, that's not very likely. But it's much more about looking ahead. So what we will see for the future, how will our world as inventory compilers change in the near future? And to be honest, I don't think we're always very good at that, because our task is really to look back to look at historical emissions to make the best estimate for last year. But how it will be in 5 years' time, we will probably see when the time comes. But that should change, especially in the light of the current issues surrounding climate change. I will try to give you some examples of what that will be like and where we will face big trouble. So first of all, and Greet already mentioned that at the subnational to local scale, uncertainties are much higher. Then we don't know so well anymore where the emissions take place, what fuel is exactly burned. And we recently published a very nice paper, my colleague Ingrid Super, which is available online. And I will not discuss that very much more in this presentation, but it convincingly shows that we really have some work to do there. And it's important because mitigation will occur at that scale. We will address an individual plant for the electrification of a system will take not place at the national level, but at the subnational level. Then I think maybe that's like an open door, but climate change is really a global problem. And while I've shown you that these very nice, very small uncertainties for Germany, countries' inventories, they differ a lot in their uncertainty. I'll show you that as well. Another important reason, and that's why I'm saying this having this looking ahead sign, is that we need to realize that complexity will really increase over time. And there are many reasons for that. I'll show you 3. As also was said in the beginning, inventories, they are and they will remain crucial to design action because they have very detailed source sector information. But measurement-based data can really increase the transparency and most of all help building trust. And if there's one thing we need as an inventory compiler, that is trust in our inventories. And then there are always surprises. So if we look at the climate change and therefore CO2, it's really a global problem. And what you see here on the left-hand side is a graph which gives you the total emission of CO2 by country or region over time from 1990 to 2020. And there's a lot of information in these graphs, but I'll just point you to a few things. So in the left-hand graph, the green line is actually the European Union. And you can immediately see that this green line, although it's important, the rest of the world is a lot more important. So our emissions are a full part of what is happening in the world. And we need to remain aware of that. And if you then move to the right-hand graph, this gives you the emissions per capita. So how much CO2 do you emit per capita? And again, I will guide you to 2 important lines. So the big black one, that's the global average. So as we know, the European Union, the US, we are above the global average. Other countries are below the global average. So for example, look at the lowest line, this is India. So if India would move up to the global average, which is, this is not unfair, this could happen, but you take that information, you can see that India is now a factor of 2 or 3 below the global average. If you take that back to the left-hand side and you look for the purple line, which is at the same level as the European Union at the moment, they would sort of double or triple there, and it immediately would become the second most emitting country. So things could really change dramatically in the future, and our emissions, while important, are only a very tiny part of it. And focusing on our own problem really is, in my opinion, a no-go. We need a global approach. And there's also a very interesting paradox, I think. While every country makes annual emission inventories and learns more and more and becomes more accurate, the overall uncertainty is growing. And that is for the very simple reason that the most certain emission inventories become less important. So the countries where you have decades of statistical detailed information that was referred to earlier, they are actually becoming less important than the countries where these statistical informations are not as good. And therefore, the overall uncertainty is increasing despite the fact that everybody becomes more certain. It's a very interesting paradox, but I think it's a reality. And that leads us to some very important issues because, for example, in the Netherlands, we will pretty soon celebrate 50 years history of emission inventory. But many countries that still need to build their inventory system in a good way. They don't, and they will not have 50 years to actually build that. So we need new ways to move to a higher quality level in a much faster time. And we can ask and maybe speculate that satellite data for greenhouse gas monitoring, they may function a little bit like the mobile phone in Africa and allow countries to leapfrog to a much higher level than they would do if they would just go step by step in the, let's say, traditional way. Then I'd like to explain to you that I really believe that complexity will increase with time, and it actually will increase a lot. And not everything will be solved by looking at greenhouse gas emissions from space, but I think it will really help. First of all, it was already pointed out, the Paris Agreement and the national determined contributions. If you look into that, over 80% of the countries include land use change and forestry in their mitigation contributions. But we all know, and inventory compilers know very, very, very well, that these are really difficult to monitor. It's very, very challenging. It's much harder to establish good estimates of what LULUCF sector is doing than, for example, what a coal-fired power plant is doing. So this will really be a challenge. Another point is that biomass as a fuel is increasing. And while that is encouraged from a climate perspective because it's short cycle carbon, there are now being questions asked how real that is and if it's not more complicated than being simple carbon neutral. And for this, I add a link here to the Scientific American, and I think the title of that link already says it all. It says, Congress says biomass is carbon neutral, but scientists disagree. That doesn't mean that scientists are by definition right, and just to point out there's a real debate about this. And to show you that the share of biomass and fuel use also in Europe is an issue, and it will complicate things, is that you see here in this bar chart, you see the European countries, and they're all ranked according to the share of biomass or biofuel use in their total anthropogenic CO2 emissions. So you see there is already quite a number of countries where this is 25 to almost 50%. So this is increasing, and it will again make it more complex than let's say, just between quotations, monitoring the fossil fuel CO2. Another nice example, I think, of how complexity might increase is that if carbon capture and storage might become important. For example, and carbon capture and storage means, for example, you have a coal-fired power plant, but instead of emitting the CO2 into the atmosphere, it's captured and it's stored, for example, in an old gas field. So in that way, you would really reduce your CO2 emissions. But this will completely decouple the CO2 emission from the amount of fuel combusted. And then suddenly we lose our anchor. It will no longer be so easy to estimate how much CO2 is emitted from that power plant if CCS is in place. And what I show you in this graph here is not about CO2. This is about sulfur dioxide, so SO2 emissions, where we did a study together with Environment Canada using the CO2 retrievals from the OMI instrument and the reporting by country. So the black lines, so you see panels, each panel represents a country, and the blue lines with the arrow bars represent the observations from OMI for those particular power plants. And you can see that actually the instrument has in a particular year, it has quite a lot of variation, but overall it follows the trends really well. But you can also see that for some countries, there are really discrepancies between what is reported and what we see from space. And of course, these then need further investigation. And so I think that's already a very good example that this combination of space data for point sources and inventories, it already exists and it is possible. It needs, of course, a lot of cooperation between both the satellite-based community, the inventory community, and maybe also the national governments. But it can be done. And last but not least, surprises. And the best way to prove that surprises are real and that they can be really significant is to look back in time. And I just pick up one, and this is the result from, if you go just 5 years back, August 2015, and you remember from my first slide how important the CO2 emissions from China are. They are the world's biggest emitter. Just 5 years ago, suddenly scientists revised China's emissions downwards by 14% because they had new coal emission factors. So this is really a massive change. And then, not even a few months later, China's coal consumption statistics were reevaluated upwards by 20%. It's, I guess, a little bit fortunate that these things sort of work against each other and not both in the same direction. But still, this shows that there can be really big surprises. And that is also illustrated in the graph that I show you on the right-hand side. This is from a recently published paper in Scientific Data. The blue bars show you the energy consumption in coal equivalents, and all the different lines, they are different inventories. And just look at the grayed area, which is actually a gray shaded area, which is the uncertainty surrounding it. And you can see that this is really, really large. And this is important also at the global scale of CO2 emissions. So we really have a large uncertainty still, even for what we would call the best known pollutant. And while I cannot predict what the new surprise will be, I can predict that there will be new surprises.
Hugo, 2 minutes, please.
Yes, thank you very much. I'm here at my concluding remarks. So we all know that limiting dangerous climate change is about reducing atmospheric concentrations. And so inventories are a means and not the goal. And that's also true for inventory compilers. But if you look at all the complexities and how things will change in the near future, I think it's fair to at least pose the question or the statement that current inventories, we really have to ask whether they will be sufficient to monitor the effectiveness of climate policy. And I think we will need extra tools and help. Of course, bottom-up national inventories with detailed source sector information, which you cannot get from observations in the atmosphere, are and will remain crucial to inform, to negotiate, and to design action. But measurement-based data increase the transparency, and they really help building trust between parties. And of course, they can confirm trends. So data from, for example, the CO2 emission and traditional inventories are complementary. We need both, and they will strengthen, not replace each other. So I think, indeed, that global independent verification may become extremely important, and that the global importance of non-European emissions, the increasing global uncertainty and complexity, the necessity to monitor mitigation progress, make a CO2 observation from space a highly valuable asset also for inventory compilers, or maybe even especially for inventory compilers. And with that, I thank you for your attention.
Thank you very much, Hugo. So, without too much ado, I will give the floor to the next speaker, which is Stephen Briggs. I think quite known in the community through his role in so he will give us the view basically in relation to the UNFCCC Paris Agreement. Stephen, the floor is yours. Stephen, you appear still to be muted.
Stephen, you are now unmuted, and you can control your presentation with the toolbar on the left of your window.
Can you hear me now?
Yes, we can.
Now you can hear me. Thank you. Thanks very much, Hugo. Paris Agreement has already been mentioned, and what I'd like to do in 5 or 6 slides is just to try and draw the links between the Paris Agreement and the work of the Copernicus program, in particular for CO2 monitoring. So what was agreed at Paris in the Paris Agreement? Firstly, a fundamental point was that there was a new approach. So moving away from Copenhagen with trying to find a single overall agreement, Paris moved to the point where we had these, as you've already heard, nationally determined contributions that individual member states would state to their parties their intentions for the future emissions. And these would be revised on a continuing basis every 5 years. The overall agreement there was to limit the increase in average global temperature to below 2 degrees, and to pursue efforts to limit to 1.5 degrees above pre-industrial levels. And this was something of a compromise between different parties. You will remember that since that time there has been a special report from the IPCC on essentially looking at the difference between 2 degrees and 1.5 degrees in terms of the outcomes for the Earth. And there are significant differences. That means that 1.5 degrees, it would be a significantly better outcome than 2 degrees. Emissions should peak as soon as possible, and all countries should contribute. Now, we've heard about Annex 1 countries. There is no Annex 1 in the Paris Agreement, but developed countries should take the lead still. But for the first time, all countries should enhance their mitigation efforts, as opposed to previous agreements, which really put the emphasis only on the Annex 1 countries. So everyone needed to contribute. The initial intended contributions, if you sum those up, would be equivalent to about a 2.7 degree temperature increase. And in fact, this is already a reduction on where things were going beforehand. But if countries stuck to what they said they would do in Paris, then we would have a 2.7 degree C, roughly. So there's an improvement on that which is needed to get down to the targets. The revised commitments would be renewed every 5 years, as you've heard from Greta already, and always in a downward direction. So we ratchet downwards in the emissions. They would be essentially verified and looked at through a global stocktake every 5 years. And I think it's important that we don't see this as being some sort of central policing of emissions, but more a process which allows countries, as Ugo has just said, Ugo van der Haan, to improve people's estimates of their own emissions through their inventories by providing better and independent information coming from a monitoring verification system to allow them to ensure that their inventories are more accurate. And using the 2006 and 2019 updates of the IPCC methodologies. It's important also that we consider one of the subsidiary bodies to the parties, the subsidiary body for scientific and technical advice, a SUBSTA, which provides, as it says, scientific and technical advice to the parties in how to implement the agreement. And it's, I guess, no coincidence that the approach that came out of SUBSTA was very much consistent with the CO2 report of the EC and the approach that the EC has taken. And I say we should put it the other way around. The EC report is essentially responding to the SUBSTA recommendations. That we have a need for multiple elements of the system. So there needs to be a system of space-based measurements for atmospheric concentrations of CO2. That needs to be complemented by ground-based flask measurements and tall tower measurements. But these need to be brought together through transport models and a system of assimilation and reanalysis to be able to continuously review the consistency of the different measurements which are being made. One needs to be able to, as Fred already mentioned, assess the geospatial distribution of emissions, to be able to set that out and to understand the relationship between concentrations in the atmosphere and emissions from the ground. And this is a very complex technical problem, but one which is absolutely critical if we are to try and understand and support the agreement through the work of Copernicus. In terms of mitigation and relation to science, then we must see that we must see the benefits coming out from mitigation, and these need to be, the understanding of those benefits need to be the basis for how the mitigation rules are set up. In other words, mitigations need to be dictated by the benefits which follow to society. There are specific references in the Paris Agreement to REDD+, reduced emissions from deforestation and forest degradation, and that relates also to measurements of AFLU, agriculture, forest, and other land use. In other words, changes in land use which are specifically mentioned as part of the mitigation elements within the Paris Agreement. The NDCs also include national adaptation plans. We tend to think of the global stocktake also requires, it's not only about emissions, the global stocktake also requires parties to develop national adaptation plans to demonstrate how they're going to respond to changing climate. because whatever we do with mitigation, climate will continue to change and we need to adapt to that. There's also a requirement to provide data and services for the special reports to the IPCC and to support the basic underlying science. And we mustn't forget that information, data and observations are needed in order to be able to support that and to support the methodologies of the IPCC. So all these are important reasons for getting better information. We need to be able to support the stock-taking methods for the global stocktake. And this is where clearly the Copernicus CO2 program we're talking about comes in, but also the land service, which is important in terms of looking at land use and land use change. In order to support other mitigation measures, we need to look at the land use change, as I mentioned, using the Copernicus land surface and the other sentinels, 1, 2, 3 in particular. For providing for adaptation, which is a very important aspect of the Paris Agreement, particularly those countries which are suffering, one might say, most as a result of climate change, then adaptation is an extremely important element, and support and information for adaptation is another important output from the Copernicus system as a whole, not just the CO2 MVS, but also the other parts of the Copernicus system. I think, and this is something of a personal view, that we need to provide better societal information about climate change and improved indicators of the consequences of change for society as a whole. I don't think that just talking about temperature is sufficient. We need to be able to demonstrate what the consequences of climate change are in ways which are much more tangible and much more real world for people to understand what's going on. Also for politicians to demonstrate what the benefits of the Paris Agreement are themselves. Loss and damage is a very important and a very crucial phrase within the Paris Agreement, and this requires information on disaster risk reduction and mitigation, and this again can be supported through the overall Copernicus program. And I think, again, this is something which is emerging, and something of a personal view. We're going to have to be able to combine complex data, not only on the geophysical aspects of climate change, but also on the social and economic ones. And here I believe that there's a major contribution to be made by emerging technologies in artificial intelligence, combining different types of knowledge in ways which are a priori inconsistent with each other, which need to be able to be brought together in order to understand the wider societal aspects of climate change. So that's a real challenge for science as well. So in summary, what happened at Paris? Firstly, it was a tremendous success. There's no doubt about it. The French government made enormous efforts to ensure that there was a success in Paris, and they were brought forward. If we hadn't had such a success at Paris, it was very difficult to see how the world would have progressed from there. The discussion was very much about the process rather than the substance, but that's also very important, and very good progress was made. However, implementing the Paris Agreement is important. Just signing up to the agreement is clearly not enough. The temperature targets, which even 2 degrees and certainly 1.5 degrees, are extremely ambitious and will need there to be substantive changes in the way that society operates. And those need to be monitored, measured, and famous saying, you can't manage what you can't measure. We need to be able to measure and understand the trend of emissions worldwide, and this is where the CO2 MVS really comes into play. And again, this is a personal view, but I believe that I'm an optimist, and I believe we will succeed in modifying the way that society operates. But we will do that because of the economic benefits which come as a result of it, not despite the economic disbenefits. And this is why I think that the private sector, commercial industry, and businesses are going to be extremely important in implementing Paris Agreement. The agreement is an agreement among parties, in other words, amongst governments, between governments. But the way that it's implemented will be primarily through industrial activity, and the economic aspects of that are going to be critical. So we need to look at this as a holistic societal problem, rather than one simply of science and policy. And the real world means that we need to bring along, and in fact, I think industry and those businesses which have more foresight see this as an opportunity, not as a threat to their businesses. So thank you very much, Hugo.
So thank you very much, Stephen, for this very interesting thoughts. And I can share a lot of what you just indicated here. I think this brings us almost on time to a short break to refill coffee and so on. I'm afraid in this format everybody will have to cater for his own coffee, so the commission coffee is not available to neither panelists nor participants. So I would ask you then to be back online in 10 minutes, being 10:45. Thank you very much. So, hello from my side. So I think we should restart after a short break. So I would now like to invite my dear colleague Bernard Pinty to give us a general overview on the system and the capacity we are putting in place in the next years, and so basically providing sort of the reply to the challenges outlined in the first session. So Bernard, please go ahead.
Thank you, Hugo, and good morning, everyone. I see we have quite a number of people being connected, and actually this is the right thing to do if you want to learn more about all the scientific and technical aspects of this initiative. On my side, I'll be using quite a limited number of slides, only 2 actually, and I'll let you get the first slide popping up. Next slide, please. Oh, it's me. Yep.
Can you see your second slide, sir?
Yeah, I was supposed to have some animation on this one. Okay, never mind. So the slide is very busy. Actually, I was supposed to show that in a sequential form. Title first. This is about the roadmap. I'm going to focus a lot on this roadmap because this is what matters maybe more on what we are saying. The words have been carefully selected here. You can see the first word is operational. Operational has different meanings from different people, but in that context, I would like to highlight the fact that operational means an operational program like Copernicus, that is some sort of a guarantee that you have long-term funding and resources being devoted to this endeavor. So that matters a lot. Well, after anthropogenic CO2 emissions, that's clear, and we'd like to contribute to not only the monitoring, but also the verification process, which have been setting up and putting in place in the context of the Paris Agreement and all, the things which happened after COP21. This is support capacity. We are going to help people dealing with current reporting. It's not competition. I think that was made very clear by previous speakers in the session, by Great, Hugo, and Steve. Now, what's important on this slide is the time frame. You see the time frame here going all the way from 2015 up to 2028 and more. In fact, this slide helps us to understand where do we come from, where we stand, and where we go. So where do we come from is clearly 2015. We had COP21 with the Paris Agreement, and Steve has been very eloquently explaining, what it means for all of us, our countries actually. And that was really, that's really a big game changer for whoever is concerned by CO2 emissions and greenhouse gas emissions in general. Now you see that when we have these global stock takes, we are going to take place every 5 years. The first one will be 2023, it's highlighted here. And clearly, it's going to be depending on inventories with data acquired, statistical data acquired 2021. That's a bit short, for us to really do something significant from space, actually. And we target the second one, 2028, second global stock take. I'm just wondering if you see my my animation here or not. Do you? Hello?
Yes, sorry. Unfortunately, animations are not displayed on WebEx.
Okay, fine. It's a learning process. So 2028, second global stock take, inventories based on data acquired 2026 mainly, to get things being ready, prepared, analyzed. So we have to be ready by that time with what we're actually setting up. On top of this slide, you see the CO2 monitoring task force. It happened to be so that, in fact, the Commission was anticipating this sort of need for anthropogenic emission that is to begin with the context of the Copernicus program. You know that we have been putting in place a climate change service, and definitely when you have a climate change service, you need together with the atmospheric monitoring service, to have something to say about what's happening with one of the most important greenhouse gas contributing to climate change. So in fact, during year 2015, we have been working with a series of a group of experts, international experts, where basically we're asking this question: do you think it's worthwhile doing something from space? Is that going to be useful and helping us in better understanding the emissions, especially those coming from main activities? And we issued this first report, which is the Blue Report, CO2 Blue Report. It was issued actually before the COP. It was issued in October. So obviously, when the COP came into play with this agreement, that was a real boost, to what we are doing. And this task force has been working hard. And you see here, I want to highlight 3 reports that you have on top: the blue, the red, and the green. And the red report is telling us, really, is trying to shape up what is this MBS support capacity, monitoring verification support capacity. The other report, which came actually last year, is the green report. It's all about in situ, because space is not, let us say, able to help us to completely solve the problem in standard mode. We need more information, and we do need in situ data. And that's going to be the topic for tomorrow's morning session, which will be, which I will chair, and we will have a series of talks about what it is that in situ can help in the process. Below the timeline here, you see also very important contribution. This is the MRD, so-called mission requirement document. This task force has been contributing to setting up the very first mission requirement document onto which the ESA, EUMETSAT could base, their activities. So this is quite an important document that was established at the time and made public, by the way, so you can have access to all these documents as you like. Next to it is CIOS, the white paper, which was, coordinated by David Crisp with fantastic leadership. We are into it, and actually, because we're a little bit maybe ahead of other colleagues, and that we had already, these blue and red reports being ready, we've been contributing quite significantly. And it shows how important it has been for us from the very start. And I have to thank here Mark Doyle and Asco as well for helping us, in stepping into this international arena, so that we are now, full partnership with US, NASA, JAXA, and Chinese colleagues as well. Now, you understand that taking data from space means basically we have access to what we call concentration. That is, we are sensing how much CO2 is in a given column at every point in time. But it's not exactly what we're after. We're after fluxes. We're after fluxes coming from the bottom due to anthropogenic activities. And that's not at all a done deal. I mean, that's very complicated. And that's why we need to also do specific and dedicated research to be ready with at least the prototype and come back in that moment. To do so, we have been having a number of research activities. So all big institutions contributing to this endeavor are actually setting up studies to support, what sort of work that they have to do. That's absolutely relevant for ESA and EUMETSAT. And the Commission obviously has been launching quite big research calls, which were well answered and which basically have been mobilizing the community. And I'm talking about the European community here, living on board, research labs, living on board industry, on board different people that could actually really contribute to this challenge. And here, there has been quite some work, during the preceding years to set up 2 very significant research activities. One is under CHE, which is led by ECMWF, by Richard. We'll hear about Richard in a few minutes. And the other one from Verify, which is led by Philippe Perrin from LSC. Both of them are actually joining. There are very good bridges between these 2 projects, where basically all the communities, which basically all the communities is contributing. So that's quite an interesting action as well. And I have to thank here my colleague from DEFIS, Christine and also, and obviously the continuous and dedicated support from REA, particularly Monica Kachik. This will help us in building this prototype that you see here. We're planning to be ready with a prototype with limited functionalities, but the main functions being in to see how much we can do, for this first global stock take, not pretending we'll contribute as much as we could, with all data from space being available, but we plan to inject as much as data from space observation that we have. I'm thinking about obviously OCO2, OCO3, the GLOSAT series, and TANSAT, if and when available, and any other that will be flying at this time. That will include microcar, by the way. So the main objective is this one. This is this line, vertical line here, 2026, being ready with full operational capacity. And that will include the CO2 satellite constellations. And my colleague and friend Yashka will come after me and tell you all details that you need to have about what it is that we are going to fly actually to make it a success. It's clear that we have challenges all over the place. This is some sort of an uncommon mission. We have a deadline. It's not at all like when we plan, space missions in a more relaxed, I would say, quote unquote, research program. But it's also clear that we are facing an emergency situation. We are facing dramatic changes climate. Yesterday I was reading that Verkhoyansk has been reaching over 35 degrees temperature. It's quite scary when you think about it. So it's definitely our responsibility not only to do it, but to make it a success. And I would like to really, thank all the people who have been contributing to it. So maybe, I know that it has been very significant support from, a number of people. And with my next slide, I would like to highlight the fact that we have on the top left all the logos. Here are the three institutions contributing under the leadership of the Commission to this endeavor. That's basically our two space agencies in Europe and the CMWF. We have here, world-class institution that can definitely contribute very significantly and make it work well. You see this line now with different colors, and this one is illustrating the complexity of the next step that is beyond the space observations. Richard will explain what it is, but basically, to make it short, you see the blue colors, observations. The one which is coming from satellite is only the one at the top. All the rest is needed. We need more observations from in situ, and we'll hear more, tomorrow morning about that. We need also to have prior information that's going to come from all the various statistical data that are actually made available, plus different other indicators. We're going then to put them into a very, very advanced, complex system, which CMWF is, very famous for being able to set up and make it running. The outputs, I've not been commenting on the outputs. I'm sure it will come during this session as well. We target different scales, clearly the global scale with global stock take and so on, but we should not forget that we have the capability to go at much higher resolution, space-time talking. So we have something to say about emissions at the city scale, for instance, at seasonal, if not monthly scales when it's favorable. And last but not least, you see on the top red color this decision support system, because this is the beauty of the Copernicus program, which is sort of pushing us into bridging and linking the policy demand to our capacity in doing something really, really useful for decision and policy makers. So before giving the floor to Yashka, I'd like to take one more minute to really thank the colleagues who have been very close, to me during this year. They've been, huge efforts. They have been very, very patient with me, including, the fact that I didn't want to bargain anything, to concede any any month, when we are talking about this timing, 2026 being the strict deadline. I've been giving them a hard time, this I know. Now, on the side of people who have been really, really close are obviously my GRC colleague, Greet. You have heard about Greet this morning. Mark Dowell as well. And Defis Hugo Zunker, who is chairing this morning, and my colleague Christina, who is leading the CAMS, the Copernicus Atmosphere Monitoring Service. CAMS is going to be the main implementing entity together with the Climate Change Service at ECMWF. Things are in good hands. Also, obviously, colleagues from REA and Monica Keshik have been extremely important in supporting, all sort of activities that we are planning to have. Obviously, many friends and colleagues from all these institutions I've been mentioning before, and it's very clear to me that all things are going to go well. If you talk to any of these people, don't hesitate because you are talking to the right person. Thank you, and thank you, Go.
Thank you, Bernard, for this very helpful and kind words at the end, in particular. So I think this is basically the overall scheme and the overall framework in which the next presentations have to be considered. So we are starting with the satellite component, space component, and this talk will given by our partner in the implementation of the program, ESA, namely it's Jaska Meyer from ESA, who will present space component. Jaska, the floor is yours. Thank you.
Thanks, Hugo, and thanks, Bernard, for this nice top-level overview. I hope everybody can hear me. So I will present the space component, which is one of the major observation components in the picture that you saw last from Bernard. So I work at the European Space Agency, and we're implementing this space component. So from the reports presented by Bernard, we have this outline of what are the overall system objectives. And it's ranging from, let's say, detecting of hotspots and monitoring of these hotspots emissions to larger scales, which is going to more country level scale or even global scale, where you are looking at the global stocktake. And if you look at it in terms of a space component, there are contrasting requirements. So the accuracy requirements for the global system are much more demanding than if you go to more local scale. But at local scale, you need a lot of temporal revisits and very high spatial resolution. And this is something that we had to trade off in our space segment design. Yes, so why are we actually interested in these local emissions? We have seen a little bit already in previous presentations. I just want to highlight here that point source, so this is showing you the cumulative area on the x-axis. By the y-axis is the actual cumulative emissions. And the point sources are by far the largest component in this. And then secondly comes the emissions from cities. And they both account for over 70% of the global emissions. And in this emissions, they're coming from a very small area of the globe, but you need to be able to go there. And with a space segment, you can actually revisit them. So there's an example on the right. So 90% of the emitted area emissions over in Europe are coming from 8% of the European area. And most of them actually from point sources. So if we now go to how can we do this with CO2 monitoring by satellites? So we actually have to conclude that in current satellite missions, we have, for example, GOSAT from Japan, OCO2, and then there's TANSAT from China, Microcarp, which is a French system. They're actually looking at very accurate measurements. So it's more like this global picture, and you can do with this global picture you can do biogenic fluxes, which is a very interesting research topic. But if you really want to go to anthropogenic monitoring, you need to be able to image your in this example, there's a city on the top, and at the bottom there's a country. If you have this very pencil stripe or sampled measurements, you cannot say anything about or not enough about the anthropogenic emissions. So in this plot, there's actually 240 kilometers minimum, a bit more swath width, and you can actually see most of the UK in this case. And if you look at the city, it's here limited to the city boundaries, but it's really mapping the city at a 2 by 2 kilometer scale. And by doing so, you can say something about your anthropogenic emissions. So if you go one step further, if you look at CO2, CO2 is a long-lived trace gas, and that's actually why it's a climate problem, because it doesn't disappear easily. So if you look at here, you see data from the NASA CO2 satellite. There's this very narrow strip, which is CO2 measurements, and then the background image is NO2. NO2 is a short-lived air pollutant from high temperature combustion, and in this case, it's coming out of a power plant in South Africa. And if you look at NO2, it has, because it's short-lived, it sticks out to its background, but it's also short-lived and you don't really know how long it's living, emission factors are changing. So just doing NO2 to infer CO2 would not be enough. But in this case, if you would actually be able to measure both, you can actually locate the plume. And if you can see in the bottom left picture, you can see that if you don't know where the plume is going, you don't really know where your CO2 is going. And this is very important in the final emission estimating. So this is basically building the case for having also measurements of NO2. And if we then go to the space segment requirements, you can see here that we are targeting a very high spatial resolution for this kind of measurement of 4 square kilometers. On the bottom right, you can see how that would map power plants, in this case, power plants near Berlin. And this area on the left, you can see that with CO2, you can see faint signs of CO2. But if you would measure NO2, you can actually locate where the plumes are coming from, and you can use those locations to actually infer much better and much more accurate the CO2 emissions. If you look at our requirements, we want to measure 0.7 ppm. That means parts per million. So that's a very low concentration, but that's actually what is causing the climate problem. And the systematic bias of these emissions, we need to measure it with 0.5 ppm. And actually, if you look at the background levels of CO2, it means 0.15%, which is extremely demanding. But we are able to deliver this with the system that we are having in mind. So NO2, highly accurate, wide swath, and we're actually also targeting to do measurement over water. And for there, you need to do so-called glint observation. So you're looking at the glint spots because there's much more reflection in that direction. And there's an impression of several satellites measuring on the day in July in this case. So if you then go to more the hardware requirements, don't pay too much attention to this for the people that are not familiar with these kinds of observations. We're targeting very spectral ranges that are measuring NO2, which is invisible. Then there's near infrared and shortwave infrared, where there's information about the CO2. And actually in that same band, there's also methane. So we'll also be able to measure methane together with the CO2. The type of measurements that we're targeting is actually what we call a so-called push broom spectrometer. So you're actually in the flight direction, looking across the flight direction from left to right with a 250 kilometer field of view, and you're push brooming over the Earth doing your measurements. A very demanding requirement on spatial co-registration, very good geolocation knowledge, and very demanding radiometric accuracy requirements. So then what do we do other, especially than other missions that are currently flying? So current flying missions need to correct for effects from aerosol and clouds. And actually they need to filter out a lot of the data where there's too much aerosol. And you can see in the bottom right, aerosol amounts over the globe. And you see, maybe it's not that clear where the boundaries are, the country boundaries, but actually the brownish clouds are over Africa, but also over India and China. And India and China would have too high aerosol amounts for doing proper CO2 measurements. And you would actually have to filter out those data, but those data are very important for global emission estimates. So what we're actually doing, we're going to measure these aerosols, and that would allow us much more accurate CO2 data. We don't need to filter out these data. And on top, we would be able to extend over much larger areas of the globe. Another interference is by clouds, and we would actually like to measure where the cloud cover is, and we have a dedicated cloud imager. That's actually what's represented on this slide. So we are targeting to have multi-angle polarimeter measurements, which is actually viewing in several directions measuring also the polarimetric state of the light. And in this way, you get all the aerosol properties that are interfering with your CO2 observations, and you can actually disentangle them. So you can actually measure CO2 much more accurately in presence of aerosol. The spatial resolution will be over the same area of the CO2 measurements, and the requirements on it are quite demanding. So it's really state-of-the-art measurements for measuring aerosol. But we believe we are able to do this, and we will be embarking this on the satellite. So cloud imager. So in order to distinguish very small clouds, you need to be sampling at a much higher sampling rate than for the CO2 measurements. So we measure at 400 meter spatial resolution. We have a band in the visible. It's the top line. That's mainly for the low clouds that are closer to the surface. Then there is one band for co-registration between the different observations. And the last band is in the infrared again, and that is actually to measure the very high clouds, which are cirrus clouds. And they can be very thin, but they can be interfering in the observations of CO2. So if we then go to the overall planning status and the observations, so we have established together with a group of experts and the European Commission, the mission requirements. You can find that in this link. Hopefully we will make the presentations available so you can actually have a look at this document. The ESA funding, so the Copernicus program is co-funded by ESA and the European Commission. The ESA funding for flying the satellite is being confirmed at the ministerial conference last year. Since that confirmation, we have then started the tender process. So the tender process requires that 2 of the 3 satellites will be delivered by mid-2025 in order to meet a very stringent timeline that Bernard has presented. Then we, in response to this tender, we received proposals in February of this year. And meanwhile, they have been evaluated by ESA. And this resulted in a procurement proposal, which is now in the hands of the ESA member states to be approved. And we hope we get the approval on the 1st of July. And that would allow us to start the negotiations, and then hopefully we will be able then to kick off in the second half of this year, which is highly needed because we would need to meet this very stringent deadline. So the preliminary satellite design is then immediately on its way, and we hope by mid next year to have this preliminary satellite design, which is also in timing as such that it coincides with the decision being taken on the EU side for the multi-financial framework, which is actually providing the funding for any of the recurring satellites, and also to provide for the launch services in order to meet our launch window that we are flying by the 1st of January 2026. So all very demanding, but I hope I managed to show you that we have put together a very great set of requirements, demanding but feasible, and a launch schedule and a timeline that is very demanding, but also there we are on track and things are happening. And I think with that, I would like to conclude the presentation and thank my partners in this. Thank you.
So thank you very much, Jaska. So perfectly on time. So that's very good and very concise. I think we have understood that there are this ambitious program ahead. Now we go to the from the satellites themselves, we go now to the ground segment, the corresponding ground segment activities. And here I would invite Rüdiger Lang from EUMETSAT to talk about this and the state of play of the ground segment there. Rüdiger, the floor is yours.
Thank you very much, Hugo, and thank you very much also to Bernard and Jaska for this nice introduction from Bernard and the nice outline from Jaska's side on the space segment component. indeed, I want to tell you a little bit about EUMETSAT's plans to develop the ground segment for CO2M and to prepare for operating the CO2M mission in 2026. So just to give you a little bit of the context in which we would like to place CO2M in that time frame. I mean, as probably a lot of you know, EUMETSAT is operating a large amount or quite some operational satellite missions for Europe. So you probably know the Meteosat second generation in geostationary orbit, producing data for NWP for the weather centers in Europe and the European Center. And all around the world, of course, at high temporal frequency. And we're currently preparing the third generation for Meteosat, which will be launched as a two-platform constellation, where actually the second one, the sounding platform, is embarking also the Copernicus Sentinel-4 air quality geostationary mission, which will give you an hourly view on air quality in Europe, and we're currently also operating the EUMETSAT polar system, so basically moving from GEO to the low Earth orbit. METOP-A launched in 2006, and just recently we launched METOP-C, and we're preparing also there for the second generation METOP-SG in the 22 time frame, which also will consist of two platforms, a sounding and a microwave imagery platform. And the sounding platform is actually embodying the complementary air quality mission Sentinel-5 from Copernicus, providing the low Earth orbit global view. We are operating JASON-2 and JASON-3 and very much looking forward to the launch of JASON-CS, the Sentinel-6 this year actually, and for the ocean measurements and ocean altimetry. And then last but not least, of course, we have launched Sentinel-3 and Sentinel-3A, ESA has launched Sentinel-3A and B, and we are operating it since then. And this is actually the context in which we want to place CO2M in the time frame of 2026, and so hope that by this also CO2M can make use or benefit from the vast infrastructure that we have on operational missions. And you can see, because Bernard was touching on it in this context, operational really means quite a history already built up with these kind of missions, and quite some perspective, long-term perspective in the future. So we are doing this together for the CO2M mission with ESA. So ESA, as you heard from Jaska, is developing the space segment and responsible for this. And while EUMETSAT will be developing in the next years the payload data generation system, which we call PDGS. And then after the launch and commissioning, an initial round of validation and commissioning of the data, which will be led by ESA, the whole platform will be handed over to EUMETSAT for continuous operation, and in particular also for continuous monitoring and validation, supported also by our colleagues from ESA. So you heard about how this is all flown into the CO2 mission requirements from Bernard already, which are informed by the blue, the red and the green book and the CO greenhouse gas roadmap. And EUMETSAT and ESA are working together now currently at the joint CO2M system requirements, which is derived from the MRD. And from that, we're branching out our respective requirements for the space segment, which are have been already established by ESA, and on the ground segment, the requirements which we are jointly establishing together with ESA. How does such a ground segment look like, and what are we planning for in more detail? So on the right side, you see that the ground segment will broadly consist of two boxes. One will be the flight operations subsegment, that segment which is commanding the satellite, operating the satellite in its operational phase. And the blue box is the payload data generation subsegment. And they, of course, consist of quite a number of sub-boxes. And here I want to focus only, which be probably more of interest for you today, on the boxes in the payload data generation, which is the instrument data processing and the CalVal infrastructure. But I want to also highlight here that we have this large cross subsegment box, which is the multi-mission services. So basically those are those EUMETSAT services which we use across missions, and which actually where we can also, and also CO2M can benefit from a quite large infrastructure already established at EUMETSAT for their for EUMETSAT's operational current missions. So focusing on the instrument data processing. So instrument data processing on the ground is usually separated in a number of levels. So we're talking about level 0, where we talk about the raw data stream from the satellite. And then level 1B are the calibrated radiances derived from that. And level 2 is actually then the end product from the EUMETSAT perspective. And this is what we call then the inferred total column, for example, the total column, or mainly the total column CO2. And in parallel, and very important for this mission, all these levels have to be very closely monitored in their quality at level 0, but also at level 1B, and also at level 2, where we have a quite robust and operationally robust CalVal concept established that we have already also in place for other missions, which works directly on the data stream and is enabling us to continuously monitoring, but also regularly validating the data using databases and provide reporting to our users. And here, our main user is, of course, the monitoring and verification capacity. So in this case, it's ECMWF, which you hear about from Richard in the next talk. So basically at level 2, the total column, we basically stop our processing and provide the data to the MVS system. So looking a little bit deeper into how we do the processing, you don't need to look, will go into detail of all the boxes, but just to give you a feeling for what such a ground processing system entails and how complex it is. So the green boxes on top of this pyramid is basically the boxes where we produce the radiances for different bands. Like Jeska said, on the left side you will have the sphere, the shortwave infrared, and the near band. On the right side it's the visible band, and on top you have the polarimeter data and the cloud imager data, and those are all processed to level 1 and then further processed downstream to level 2 towards the total column CO2 and also methane and the total column NO2. What is peculiar for what we are planning for CO2M is that actually the whole system, and you see the complex interplay here, is basically working together to serve in principle only one goal, and this is the derivation of the total column CO2. And so basically we're trying to make in the ground segment a kind of a hyper instrument of all the instrument data. I just give one example. So the cloud imager will keep off first because its data, like the cloud masks and cirrus detection, is needed very early stage and is used as input to the level 1 processing which comes next. So, and all this is put on the same grid, on the target grid of the main instrument to derive the CO2. So we really target to make one hyper instrument by processing out of the 3 or 4 instruments on the platform with this. One word about validation, because because we know this, and it has already been touched upon also by Hugo in the earlier presentations. it will be very important that we continuously monitor and validate the products from this mission at a very high level. So as I said before, we plan to do this continuously and regularly in monitoring and regularly also in validation. The data in the validation will flow from the satellite on the left through the validation system, from which we then store it in databases and provide trending analysis, also facilitate reprocessing of all the data, and then produce the reporting. But for this, of course, we will need external sources to help the validation and to help the monitoring, and those are indicated here on the top. From the left to the right, we will use model data. And the model data is in that system, and the model data is particularly useful if you want to have a glimpse on how well you're performing at the global scale, very close in time, everywhere. So you would have a regular monitoring and can very fast detect that something substantially may go wrong somewhere in the system or on the platform. Also, we want to look at external satellite data because those gives us a very good reference of where we are in the context of either similar missions in terms of CO2 or similar missions in terms of class of instruments, which can give you guidance on different levels like the radiances in level 1 or the level 2 output. But last but not least, and most importantly, we will have to use ground-based remote sensing data, which will be, of course, the backbone of our validation efforts, telling us how well actually we're doing in terms of product performance. And that brings me to this last topic where I'm saying where I'm focusing a little bit on this need for ground-based measurement, also for the purpose of the space segment validation. And this where we have taken initiatives, basically starting off also from the green report, as has been reported already by Bernard, looking in the situation of the in situ measurements across Europe. We had a meeting at EUMETSAT looking more into the status of greenhouse gas fiduciary reference measurements on the ground, and of which one first result was the establishment of a report on the sustainability analysis on these ground-based networks and the fiduciary reference, which has already been issued by Copernicus and the European Meteorological Service network in around November 2019, is also publicly available, and we are currently working on a report to further look into what is needed then for a sustainable network to make the measurements on ground fit for purpose to support an operational mission. And that means really sustained continuous measurement, very well controlled, regular reporting also from the ground measurements to the center where the satellite processing is taking place. So here at EUMETSAT. So that would then bring us to operations, hopefully.
Yes. 3 minutes.
Yes, thank you. I'm nearly done. So that would then bring us to operations in sometime in the time frame of 2026, where we would have then all these inputs in place and also the on-ground networks to feed our Calval facility and to provide these operational calibration, validation, and continuous monitoring, which is desperately, which is very, very needed for this mission. So this is my last slide. And Jaska has already shown this. I'm not going through in detail. These are the products we provide, maybe highlighting that we also produce the methane and the NO2 for the plume detection. You heard from Jaska that the very ambitious requirements in the sub-percentage range for both CO2 and methane, which are actually kind of unprecedented. So we need to support this, and we need to be very accurate also with the measurements, therefore for solar-induced fluorescence, which is an interesting climate parameter in itself, but we are need to derive this to improve also the CO2 measurements in a similar way, like Jaska has said, we need the aerosol and the cloud measurements at very accurately derived in order to support the accuracy and reach the very stringent accuracy on CO2. We will produce roughly 1 million measurements for one orbit, of which we think we can use approximately 200,000. So that would convert to an output on level 2 of roughly 5 gigabytes. And my summary is that EUMETSAT, ESA, and ECMWF are joining the forces to make this happening, and for advanced bloom and background characterization from CO2M to support the European verification capacity for the monitoring of the anthropogenic CO2. And EUMETSAT is happy and looking very much forward to contribute the ground segment to this, and the operational product validation and continuous monitoring of the product. And we are also looking forward to operate this mission in an environment where I think we can make very efficient use of existing infrastructure available at EUMETSAT, so that we have we can implement this in a cost-efficient and also time-efficient way. Many thanks.
Thank you very much, Günther, for this presentation on the ground segment. And so I think I will directly go to the next speaker, which is Richard Engelin from ECMWF. And he will talk about the overall architecture and the development of the service, which is building basically on the elements we have just heard about, and is delivering a service. Richard?
Mr. Engelin, you are unmuted, so we should hear you.
He's still muted. Richard, you still need to unmute.
Hugo, maybe we can pick up a question while Richard is solving his problem.
Yes. So then that's a good suggestion. I think there were a number of questions to Hugo's presentation. So in particular on the way how the satellite observation, grid observation is contributing to the inventories. And so maybe Hugo, if he's still around, he can.
Yes, can you hear me?
A couple of words on that.
I can do that if you can confirm that you can hear me. We can
yes, we hear you well.
Okay, otherwise I'm just talking to myself. Always a bit sad. So yes, I think, well, I mean, first of all, of course, the question is like, can we give some examples how CO2M will contribute to the inventory compilation? Well, and of course, that we're talking in the future because CO2M is not operational yet. So at the moment, we cannot really do this. But I think the key point to stress is that CO2 emissions are overwhelmingly coming from point sources, from large point sources globally. So power plants, iron and steel plants, industrial facilities, and this is exactly what a satellite is really able to see very well. And we've seen that recently with the examples from Tobomi for methane, where really the point sources are detectable. So given that this is like, 60 or 70% of the global emissions, that will be a very important aspect. And that's why I also showed this example of how we did that before with SO2, and it shows that you can actually see discrepancies and you can bring that information back to the inventory compilers. And of course, it's really important that it's not one-way traffic. It's an interaction, and that was also stated in the chat. The national inventory reports, which have the completeness of all the sources, they will remain the basis. So it's really complementary. But I think there are very good cases to make. And maybe to add to that, as a final comment, the world is changing very rapidly, and for us in Europe, that's always a little bit surprising. If we want to build a new power plant, there are 10 years of negotiations or something. But if you look globally, you can see facilities closing and popping up within 1 or 2 years' time, and so we need to be able to monitor and have a grip on that, and we cannot do that by having data that is sometimes 10 years old. It will miss a lot of new point sources. It will miss the closure of old ones. So again, this is really valuable information that can be channeled towards the national inventory compilers if we have a good framework for that. I hope that mostly answers that question.
Yeah. Thank you, Hugo, for again pointing out really the complementarity and the synergy between these two approaches. So I see now Richard Englin. He seems now to be eager to start his presentation. And Richard, I think the floor is yours now. Thank you.
Thank you, Hugo. Yeah, apologies, I lost my internet connection for a few minutes. So I'll try to say a few words about how we are planning to bring all the information together, building on what Bernard already presented before at very high level, and I will go in a little bit more detail. So the grand challenge is basically that satellites do not measure emissions. Satellites measure atmospheric concentrations. They are very good in that they can provide a global view on what we have in the atmosphere in terms of CO2 concentrations. There's two examples shown here. These are actually model simulations, but this is what we could expect from the CO2 emission. On the left, a very zoomed in image over part of Europe where we can see individual plumes from power plants. But also clouds in the view, and all the way on the left we can see a much broader area of high CO2 concentrations that's actually moving. On the right, and this was meant to be an animation, but the point is probably clear enough. This is a global simulation of CO2 concentrations showing the large variability, which is mostly caused by natural exchanges between the Earth's surface and the atmosphere. And this is moving as the winds take CO2 molecules across the globe. So this is what we measure, and we need to make sure we estimate emissions based on this information and other information. And this is complicated. This is not easy to do, but it's something we think we can do by bringing all the relevant information together. Coming back to the diagram that Bernard showed already, this is slightly different version, but with the same components. The system we have in mind is exactly doing that. So we have observations on the left side. We have the prior information in green on the top, and we have a blue box which will integrate both the observations and the information we already have with integration systems, modeling systems, data simulation systems that can combine information and then provide outputs we need, both on global scales and regional local scales. And then in the end, this should feed into more user-friendly products, policy relevant products, etc. So this is a system approach that is not new to us. This is actually underpinning some of the Copernicus services that exist already. Most notably, the Copernicus Atmosphere Monitoring Service, and to some extent also the Climate Change Service. So this is one reason why we think it will be very good to expand on these existing services, make benefit of the experience we have built up over the last 10, 15 years already by designing, building, and running these operational services, and extend these to also make sure we can look at CO2 emissions as well. This also makes benefits of, for instance, current plans within CAMS to look at emissions from other pollutants as well, most notably carbon monoxide and NO2. So this all fits nicely together. Obviously, we also want to make use of the information the other Copernicus services will bring, the land service, the marine service, and the emergency service. Those have been mentioned before already, so this is important to build into the system. And we want to work together with national activities at the same time. Bernard showed this roadmap. I'm not going to go into the details, therefore. The only thing I wanted to highlight here is at the bottom that this whole timeline, which is challenging, but it's already happening. We are designing and building the prototype systems, and we have research and development support through Horizon 2020 already in place. There's the CO2 human emissions project, J, and the Verify project. Both of them are running already for a few years. And then there will be a follow-on project starting on the 1st of January named COCO2 to really design in strong collaboration with the CO2 monitoring task force and also liaising with EUMETSAT and ESA to design and build the prototype systems that can then be implemented in the Copernicus framework. Just a few words on these projects. So the J project started in 2017, coordinated by ESA and OF with 22 partners. This project is meant to support the CO2 monitoring task force in further exploring the design and development of the foreseen system. So this has been happening, resulting in various reports that are publicly available. The Verify project started in 2018 and will run till 2021, coordinated by LSCE with 40 partners. Verify has been focusing more on what can we do now, how can we already make clear efforts towards supporting the reporting process, focusing on Europe, but also looking at methane and N2O, and making use of existing observational data sets. And then, as I mentioned, COCO2 will start next year, coordinated by ESA and OF with about 25 partners. And COCO2 will really start putting together the prototype systems ready for implementation in the Copernicus program. One of the outcomes of J, and apologies for the quality of this figure, which must be due to the WebEx presentation. This is going into a little bit more detail for the high-level overview. It's the same blocks, the observation block, the prior block, and the integration block and the outputs. But it shows that we have been really thinking and trying to put more detail and more actionable information here to really start building the systems. And I will go through these blocks one by one, using some examples from the various projects to illustrate these aspects. So starting with the observations, we've heard about the CO2 monitoring mission. Obviously, this is a critical mission for the success of the whole CO2 monitoring Copernicus service element. But we cannot just stop with that satellite mission on its own. We need other information as well. I mentioned here just a few of them. We need meteorological satellite data to constrain the transport and the meteorological conditions of the atmosphere, which is important, especially for the modeling, but also to some extent for good satellite retrievals. We want to look at the land biosphere, the land surface. So we need observations that can help us with that. Land use change was mentioned already, so that fits into there as well. So these are all important things that we also need to monitor from space. We also want to monitor from the ground surface itself. So we work with in situ observation communities to see how we can make sure that we integrate these important observations into the overall system as well. For the European domain, this is mostly ICOS, although there's other research infrastructures as well that might be beneficial. On the global scale, I'm mentioning here WMO with the GOR program, and more specifically IGIS. So these are important elements to integrate into what we want to do. And this also refers back to the green report that was mentioned already, which is a full report on all the requirements for the in situ observation. There will be more on this tomorrow. Then moving to the green block, the prior information. So this is more or less what we already know, or what we can learn from inventories, from statistical data, etc. And this is actually a very important block. In order to make good use of the satellite observations, we have to have this block included. We cannot be fully independent. We have to integrate the information we do have. And I'm just showing here a few examples, both in the geographical domain, in the time domain, and in the vertical domain, going from left to right. A satellite observes a single location once per day. If we have more satellites, obviously we can extend this, but it is limited in time. If you look at diurnal cycles, for instance, also satellite observes the total column, so we need to know where the emissions have been injected in the atmosphere. So this is all very important information that we need to include to match the observations we have with the modeling infrastructure we have. So this needs a big boost in order to make good use of the observations. Then going to the blue systems, the integration components. So here the idea is to focus both on the global and the local scales. Global, because we want to provide a consistent view on emissions across the world, try to identify where we are confident that we know the emissions from all sources of information with uncertainties, and identify the areas where we're less confident and we might want to look into more detail. So the global scale, we're using the ECMRF integrated forecasting system, which is also forming the central part of CAMS already, to integrate this information from observations and priors into emission estimates. On the local scale, we would like to look at individual plumes at very high resolution, try to identify emissions from single power plants, single cities, etc. So here is an example from work done as part of the Smart Car project funded by ESA and done by EMPA, identifying individual plumes. And then also we try to connect these different scales. We try to see how we can bring information from one scale to another to fully exploit the synergies of both approaches. An important part is also the evaluation and quality control. So here we anticipate to build on the information, on the experience we have from running Copernicus service already for some time. So here are a few examples from CAMS, but we envisage similar ideas for the CO2 service. But we also want to make better use of localized high-density observation networks. There's an example shown here, but there's more examples where we can invest in infrastructure to do a very good job of estimating emissions for a certain area, to use this as a benchmark system for the more global emission estimation system. And then the final block, the red block, linking to users. So this is something that's being developed, being thought out. And for us, it's critical to co-design this with users, with the user communities. Here are a few examples shown from the Verify project, where they are already working with national inventory agencies to see how to convert the information we can produce into relevant information for the different user communities. So this is important in terms of national inventory agencies, national reporting agencies, but also in terms of cities, businesses, financial world, etc. So we need to work in the coming years very closely together with different user communities to make sure we develop something that can actually be used by these different user groups.
Richard, you have 2 minutes or 3 minutes?
Yes, I'm almost done. So
very good.
In terms of well, the discussion should then deliver a portfolio of services. We are starting this work within COCO2 next year in much more detail. Try to come with a blueprint for decision support system in its most general form, so addressing the different user requirements, engaging with policy, industry, and other user communities. And this will then be further developed within Copernicus Atmosphere Monitoring Service in the next phase to make sure we have a system that's fit for purpose and provides relevant services for a diverse range of user communities. So here, really to stress again, the Copernicus service is meant as something to support member states and cities and other user communities. We would like to work together. This is just an example where national inventory agencies, national reporting agencies, they are responsible for the official reporting to UNFCCC. Copernicus is not getting in the way of that. Copernicus is trying to support this by bringing in observation-based information. As Greet this morning already said before, with the 2019 refinement to the IPCC guidelines, there is now this option to make use of observation-based information in terms of monitoring our emissions and monitoring trends. So this is really where Copernicus tries to step in and support countries with doing this. Some countries are building their own initiatives, and there we even see a more synergetic exchange of information expertise. But it's working with member states to make this happen. And just to show that this is already a truly collaborative effort, I just listed here the different groups involved in the 3 projects I mentioned. So we're really trying to build on the enormous amount of expertise that we have in Europe. We're also linking with international initiatives because it is a global effort in the end to mitigate climate change. But this is already happening, this is already developing, and we're full of confidence that we can make this into a very useful Copernicus service element for the future. With that, I'd like to thank you for your attention.
So thank you very much, Richard. With this, I would now maybe like to open a bit the discussion part. I have seen the questions have now come a bit more live. So maybe we try to go a bit in the sequence of the talks. So I will refer now to a bit as well to my colleagues, which I mentioned in the beginning, to see how to organize these questions. I think for the first session, there have been a couple of questions as well about the Paris Agreement, the relevance of monitoring and versus the emission inventories in the framework of the Paris Agreement. So I don't know. Maybe I can invite Stephen to say a bit on that.
I'm sorry, Hugo, you caught me while I was reading the questions then. Which particular one did you want to come back to?
I think there are questions which basically say what role will CO2 observations and basically this verification and support capacity play inside the framework of the Paris Agreement with respect to the inventories, which are at the moment the source of reporting and so on. So how is the development, how is the pathway there forward?
Okay, thanks. Apologies. Well, I think as I perhaps didn't point out in my talk, when I set out the four major elements which Subster saw as being necessary for an overall reporting system, which was the ground-based measurements, satellite-based measurements, and in situ measurements, and then the assimilation and transport modeling and reanalyses. Really, this system that we're talking about today is the only one worldwide which is putting together all four elements of that knowledge. And that's why I think it's so important, because if we want to understand how best we can support countries worldwide, then we need to have all these different elements in place. Ugo spoke earlier about the fact that in Europe we can measure something between about 3 to 6% the accuracy of CO2 measurements in terms of inventories, but that's not the same worldwide. And in many countries, I suspect that the estimates of emissions are very widely wide of the mark. So this would be by implementing the overall Copernicus monitoring system. There will be a baseline consistency check, if you like, with the measurements which are coming out from all countries, to ensure that not as a way of validating or verifying or ticking a box to say that yes, indeed, we agree there is some sort of universal police agreeing with you, this is what your emissions are, but helping to, in the last slide of Richard's talk, showed that feedback system where you have the better estimates of the priors feeding into the CMS, which in turn feeds back to the better estimates then of the national monitoring system. So I would see the whole implementation of the VMS in its entirety really to be a way of helping countries worldwide, not just in Europe, but worldwide, to be able to improve their estimates of their own emissions and to feed those into the agreement. Because the agreement will only operate if the estimates of emissions coming into it are reasonably accurate. Otherwise, we're just wasting our time. So I think there's a very important role to be played by the Copernicus system as a whole in being able to support better estimates being made of emissions of countries throughout the world, not just in Europe. And that's really where I'd see if we can't measure our emissions, then it's pointless us talking about them, because we don't know what we can't monitor, and we can't see the progress, we can't manage change, we can't do anything. So there needs to be a global capacity for every country to be able to make reasonably precise measurements of its emissions to be able to feed into the system in order for there to be a coherent discussion. So this is a very important system, not just in the European context, but in a global one as well.
Yeah, thank you, Stephen, for this. I think there were maybe a couple of things I would like to get out from the word cloud we made in the very morning. So I think there were quite a number of people mentioning networking, meeting people, and so on. So this is unfortunately only in limited way possible today. So I refer again to the conversation starter after this session. There have been a number of the main impetus this morning was really on getting knowledge, getting information, elaborating on synergies. So I hope we have covered a lot of this. There were a number of people mentioning this morning in the word cloud, basically in situ measurements, the relation to in situ measurements. Here, I would like to say there's a complete session tomorrow dedicated to in situ measurements. We have as well pointed out to this as well during the talks today. There was as well mentioning basically, on one hand, concrete results. On the other hand, somebody said vision. I think we have in the first session already supplied you with our vision and our motivation for this new Copernicus element. And I hope that the second sessions have as well indicated what results we would expect from that. An interesting dimension in this word cloud was as well both the collaboration, but as well, on the other hand of this vector, the roles and responsibilities of different stakeholders. So I think this is something which will as well be pointed out a bit tomorrow, in particular when we talk about international organizations, international relations, and collaboration in the various frameworks. There has been question a bit on as well on the data ownership. So who will own the information on emissions provided by the systems? I think that's maybe a question actually for the Commission. So maybe I will try as myself to answer that. I think indeed this information will in general be owned according to the same principles as all the other services. So this means if we are using informations from third parties, maybe in situ information, aircraft data, and so on and so forth, the data policy of these data owners will of course apply. While for all data which we are producing with our own satellites, with our own services and so on, the Copernicus open and free data policy is applicable. This means that this data will be really freely available for everybody to scrutinize, to look at it. So this is really a key of our, I think our data policy is really a key of the success. So I think there will be no, this information will basically be open. There will be no hidden or no proprietary information which then is paying information or somehow restricted in distribution. I'm looking at the questions. I think maybe there are some, if we come now to the afternoon sessions, there are a couple of questions on the satellites, on the space component. So there are questions on the revisit time, which would be achievable with two satellites in 2025 or 2026. Maybe that's something, Jaska, you could briefly explain again.
Sorry, I was reading the questions. I missed your exact question. Which
basically in the question there's a question on in the slide, or there's a question on the revisit times for the which you can achieve with the two satellites.
I've seen those and I've tried to answer them. One question was related to the revisit time of the two satellites that we aim to supply for the 2026 inventory. With two satellites, it depends obviously which latitude you're looking at, but at mid-latitudes it will be around 5 days revisit time. For the full system, the revisit time would be more like 3 days at mid-latitudes. It depends a little bit on the swath width that we will finally have in our selected satellite.
Yes, thank you, Jaska. So I think I'm going to ask maybe my colleague in the back, are there any questions which we would like to associate maybe to UMETSAT or to Richard?
I mean, I can quickly answer the questions on the data provision from the ground segment. So UMETSAT, I mean, will provide through its nominal dissemination systems and data provision system the total column concentrations from CO2M. So as we said, it's CO2 and methane and NO2 total columns. And we're planning to disseminate them in a similar fashion than we've do for the other Copernicus mission. Of course, for CO2M, then also the full Copernicus policy on data provision applies. And the requirements for CO2M that we have is currently that we will provide the data within 24 hours to the users who want to use them immediately. And but everybody can go to our archive and retrieve the data from the back catalog at any point in time for free. I think that hopefully answers a couple of questions which were related to this.
Yes.
Hello. It's Eric Anderson here. I saw one interesting question that the speakers this morning might want to address, and it was posed by a colleague at EMSA, European Marine Safety Agency, and he was asking to what extent the current the CO2 monitoring facility we're talking about here, to what extent it will be able to support monitoring of CO2 emissions from ships. And there's a policy there at the EU level called monitoring, reporting, and validation of ship emissions. Maybe Richard Engeland could address that.
Yes, I can try to address that. Obviously, this is something we will look into. It probably will depend on what we in the end can observe from space. I mean, we have similar requests actually for monitoring, for instance, SO2 from ships, which is a challenging topic, but it's something that we are trying to address. Again, combined with information from the bottom-up information we have available about ship movements, ship routes, etc. But this will need further investigation to see if we can really get to that level of detail sufficiently enough to be useful.
Yes. Richard, maybe can you say something as well? There was a question, or one or two questions even on the coverage of the service. So if it's Europe only, or how can you say maybe simply a sentence on that as well?
Yes, well, it's easy. As I showed in the presentation, it's global and local basically. So yes, we provide information for the whole globe because, as mentioned before, it is a global problem. We cannot just focus on Europe only. Obviously, Europe is important because we want to work with our member states to see how we can support them with their activities. But it's global service.
Okay, thank you. So maybe I asked Eric again, are there any other questions you would like, maybe which are related to the talks, which you might want to bring forward?
Oh, I was muted. I don't have anyone just at the, well, there were several questions on in situ observations and the availability and role of in situ data, which I'm happy to see because we have a session dedicated to that tomorrow morning. There were questions about data access for research users that I thought was also very relevant. will there be authoritative data set, quality controlled on CO2 that will be made available to the research community? I don't know who that's for. Maybe that's for the ground segment, EUMETSAT.
So, of course, when it comes, as I said, when it comes to level 2, all the data will be made freely available. And that level 2, that means from our side, this is where basically our responsibility will stop at the total column concentrations, so not the emissions. But those concentrations directly derived from the satellite measurements will be available to everybody. And will be available like we make available all our data through our archive also. So those also for a researcher can go to the archive and, for example, then derive a longer time series or dedicated time series of those data, or maybe only just an individual measurement from the archive. Yes, that is definitely planned. Then if this is a question about the provision of the level 3 or level 4 or the emission products, then this is the responsibility of the overall capacity. So this would be then more on the Richard side to answer.
Sorry, I was looking at the questions. So the answer is if the data will be available for the research community.
Yes, also from the emissions side, from the level 3 and 4.
Yeah. I mean, as Hugo said, Copernicus provides free and open data. So, of course, we want to work with the science community because they normally help us to actually further develop the systems we have in place or are building. So this is a critical interaction for us as well. But obviously, the science community plays an important role in especially IPCC. So yes, the data will be available and should be used.
Okay, very good. So I think maybe I would ask for another question. There is a question related to the in situ, which Eric just said. So I suppose that's as well deepened tomorrow, but could you say something about the cooperation with international organizations in the domain of in situ, Eric, just maybe as a teaser for tomorrow morning's session?
Yeah, I saw that there was one specific question on EUMETNet. EUMETNet, not to be confused with EUMETSAT, but EUMETNet is an organization that is set up by the National Meteorological Services in Europe. And the question was whether that organization, and they do a lot of work on in situ observations for meteorology and hydrology. And there was a question there whether that organization, that group of entities, contributes observations for greenhouse gas monitoring. And I think I put an answer there in the chat that at present, no. They have a contract with EEA to provide observations, and I'm sure we will hear about that in EEA's talk tomorrow. And then there was also a question, I guess, on which organizations are involved in standardization of in situ methodology and data acquisition. And of course, the answer there is that that's WMO. The service we're talking about here for European Commission within Copernicus will depend greatly on WMO standards and processes and coordination to be able to provide calibrated data at on an international format. So that part of WMO is essential for the functioning of the in situ component of the Copernicus. But more about all of this tomorrow.
Okay. So finally, I would like to invite you to everybody to participate in a poll. There's a poll for 4 questions, which has been launched a couple of minutes ago. So these are basically questions aimed at basically how would you assess various aspects of what you have heard so far. I'm not sure what is shared with the participants at the moment on the call, so maybe we give everybody still a couple of half a minute or so to participate. I think there are about a third of the participants have voted so far. So maybe then I don't know how can we then maybe start seeing the results for the first question then?
The results of the first question are now live.
Okay. Okay, very good. Yeah, I'm not sure if everybody sees what I see here, so that's why. Okay, so basically, this is a bit about basically the underlying need or the general need for having such a monitoring and verification support capacity in parallel and in complement to the existing methodologies of inventory-based reporting that has been introduced as well. So I think what we can see here is fortunately that we managed to get across really the value that our proposed service or our intended service is going to bring in addition to the existing methodologies. So, and I think many of the speakers, notably Hugo and Gret, have pointed out very much the complementarity and the mutual benefit of these two approaches. And I think the majority here on this, those who replied here to this question clearly understand and acknowledge the importance that this is really very important or even essential to have this. In particular, seen as well in this transparency framework and within the Paris Agreement. The second question is, so maybe can we go one back? Thank you. So the second question is basically related to the overall timing of this capacity, comprising, well understood, the satellites to be there in place by and calibrated by end of 2025, as Bernhard pointed out, so that they can perform measurements in 2026 to contribute to the second global stocktake, which will be carried out in 2028. So here again, I think it's obvious that that here the timing is of essence, and again this reflects in the majority of the votes here, which really say, okay, if we want to do this, then we need to do it in time for this second stocktake. I think that's as well something which helps us to confirm our approach we have here. can we go to the third one then? Thank you. So I think here this is really about the question about the operational nature of this capacity. So here, what we intend to see means that this is really not in the domain of science, research, and so on, but this is really implemented through operational entities. So, which is clearly the case for our three partner organizations here, being ESA, EUMETSAT, and ECMWF. So, who are since decades used to routinely to produce operational products in various domains, notably metrology. So, this is, in our view, really a key feature of this service in terms of availability, continuity, and the reliability of this. If we go now to the fourth question, this is really about the integrated nature of all these elements. So basically, the diagram which was shown both by Bernard as well as by Richard. So, which means that this is really implemented again in an integrated way, so not disjunct elements, but really closely integrated elements designed in a way to sorry, I'm reading here, but really which are integrated, which are designed in a way that they really optimal work together. These chain and the fabric from satellite observations, in situ observations, modeling, data assimilation capacity, until the outputs, and even further with the decision support system, which will help policy making and support policy making in this end. So I will stop here, and I think I think that I would like to see if there are maybe some reactions to these four polls on in the questions.
Hugo, so this is Bernard here.
Yes.
Maybe a quick reaction on my side. I mean, it's quite refreshing to see that for all these questions we have like over 85%, 90% sort of supporting the sort of approach we are having, and that's quite good. I would like to highlight the fact that there is no contradiction between the fact that we go for an operational system and research aspects, because the operational system is definitely an excellent tool, to motivate research in a very oriented manner, and something which is really making sense to the benefit of the society. And same token, the system approach is key here, because not only we have to deal with different systems that need to be interlaced and talking to each other, but we need to reach the same level of maturity when we talk about the different institutions. And here what we have done is significant breakthrough that is basically having on board from the start the four European institutions. And that's quite good to see that this is all appreciated by the audience. Thank you.
Thank you, Bernard. I don't see any specific
Hugo?
Maybe.
Yes.
And this is also Hugo. Something very quickly before we close, and you can answer that. I think there is an important question in the Slido chat about the presentations becoming available after the event.
Yes.
Maybe you can comment on that.
Yes, I'm sure these presentations are going to be made available through the event of through the website for the event, basically where the registration link is. So clearly these presentations are going to be available, yes.
Maybe one small comment as well from my side, Greet here. In the questions there was as well some reference to greenhouse gases, not only CO2, and we definitely would like to see in the future CO2 is of course one of the important greenhouse gases, but also for methane and for that should be as well taken up in a certain way as well. So we should not leave people in the cold when they are not focusing only on CO2.
Yes, I think that's correct. That goes in particular for both for satellites, but as well for the has to be complemented then at the level of the data assimilation, modeling, and so on and so forth. No? So that's basically goes through the full chain of processing. Yes, correctly.
Hugo,
did I lose any?
Hugo, this is Mark.
Mark, hello.
Yes. Can I just quickly complement what Bernard was saying before, and I want everyone to be clear as well. Yes, Bernard's completely correct. Whilst our ambition is, of course, an operational system, we recognize in particular that there's still a lot of efforts to be done on the research and development. And actually, we believe, as Bernard said, that the operational ambition can actually motivate research and development investments and activities. And I just want to be clear to everyone the key role of really the chair and verify projects up to now, and the COCO2 project from next year. I mean, these are really kind of the integrating elements of this, and the areas that need, of course, a lot of investment on research and development. So I would encourage people to inform yourselves on these projects, and if you think that your entities or institutions should kind of create interfaces to these projects, then I think you should do so. But from our point of view, this is really kind of the main integrator within this system development activity. Thank you.
Thank you, Mark. I think these questions will be available still a bit, so you can see, I think a number of questions have been received as well, written replies, which we do not need to recall all of them here in detail. So,
Hugo?
Yes.
I think it might be good if you can highlight how people can follow us from this workshop on. Maybe you wanted to do that tomorrow, but maybe for those not attending tomorrow, it can be helpful if you indicate already now. So after this workshop, we will obviously work hard to implement all elements, but it would be possibly interesting to see how people can follow us.
You mean in terms of workshop itself, or?
Well, what kind of websites or services or whatever place to keep track of us? It might be best to look at CAMS or C3S, or maybe there's another dedicated website. I'm not sure how you would like to refer people to keep track of us, let's say.
Yes, I think basically I understand. So first of all, we will make a sort of summary of this workshop as well, which will be together in a certain time frame, together with presentations on the event website. Also, and there we will have a collection of links and resources to look at. in principle, these activities will be, you will find these both on at the Copernicus website. This will be continued over the next months and years. There will, as Mark has pointed out, there will be research activities, COCO2, so that will be as well a good entry point to keep track of what is going on. For ESA, of course, for the satellite component, I think as well there's on the Copernicus website and of course on the ESA website itself, you will find information. So for us, the important thing is now to our side to basically finalize the planning and for the next 7 years of the program, so the next program phase, which is still ongoing and not yet frozen. Then this process will be continuously followed on our website for the Copernicus EU. I would like to say something. There's one question I have not received the invitation for tomorrow. I think that's nominal. I think these invitations will be sent this afternoon only in order to avoid that people confuse invitations for day 1 and for day 2. So it's normal that you did not receive yet the invitation for tomorrow. So this will be still sent later today. Okay, so any other panelists would like to add something?
I think I only can add that I am open and everybody else is open to elaborate via the conversation starter. I've already got several invitations and meetings scheduled, but I'm open to anybody interested to elaborate further.
Yes, so that's maybe interesting to highlight. Yeah.
Okay, so this is Hugo from TNO. So I'd like to say 2 things then. One is that unfortunately, like I think Greet, the first speaker, will not be able to join this conversation starter this afternoon because we immediately have another conference after this where we both have to be present and present, but I will try for tomorrow, but otherwise please feel free to reach us by email. And I think as we see these popular questions on the screen now, I think is actually this question by Marina is exactly what is being tackled in COCO2, and this really needs a lot of additional research, especially this question on how we will be able to split this info in sectoral or national to be able to directly relate with the inventory agencies. This is something that is challenging, but that we can also do in the combination with models, inventories, and observational data. So I think that will be a topic for many workshops to come.
Yeah.
Hugo, Richard here.
Yes, Richard.
Yeah, maybe because it is on the screen here, just to confirm what Hugo just said about the question, which is indeed part of the challenge that I described in my presentation, and it's really where we need to bring together all the information. The satellite observations that measure atmospheric concentrations, but then also observations that can measure other aspects of the carbon cycle and the anthropogenic component in itself. The information we have from the bottom up about the different sectors, even if this information is a few years old, it's still something where we can learn from the correlations. And the different sectors have their own pattern in terms of atmospheric concentration. So we by using the modeling in between, this is exactly how we try to get a hand on the different contributions and try to get reliable estimates and reduce the uncertainties. But it's, as Hugo said, this this will be addressed, well, it's being addressed to some extent already, but will be addressed even more in COCO 2.
Okay. So I think we are coming to the end of this morning. So I would like to thank everybody involved, in particular the speakers, notably the back office, so my colleagues there, but as well the colleagues who got the mechanics of this virtual conference running, so from the contractor as well as from the commission. So I hope very much that indeed there will be next time the workshops will be again the physical meeting. So in order to facilitate as well a bit this discussion part, which I felt was a bit impacted by the virtual nature of this event. So I think I'm looking forward to have another workshop really with a physical presence again. So so I would close this morning. I think tomorrow morning for the second day of this virtual workshop, you will receive the invitations as was said in the afternoon, and you will as well. I think we will start again at 9:30. So. Basically will be the same pattern as today. So thank you very much for your attention, your patience to stay with us, and looking forward to virtually meet you, all of you, tomorrow. Thank you very much.
Thank you. Bye.
Thanks, Hugo.
Thank you, everybody.
Thanks.
Bye-bye.
Thanks, Hugo.
Yeah.
Thank you and goodbye from UMZ also.
Yeah. Bye, Rüdiger.